Hello College Algebra student. This video is for 7.3, Solve Systems of Nonlinear Equation. So in the last video, we talked about what happens if we have a parabola and a straight line, and we also talk about what happens if the systems consist of a circle and a straight line, etc. And here we have a parabola and a straight line. So I just want to briefly went over what the different types of graph that we have. Okay, so how do we know we have a straight line? You have a straight line if you have two. If you have the equation is like this. You have x and y. They're just degree 1, no square, no square root, just x and y. So you would have a line. You can have plus, you can have minus. Just change the slope, right? And then when would you have a parabola? You have a parabola if you have x squared. So you can have y plus 3x squared equal to 1. It is a parabola. It's a down parabola. You can have 4x squared square plus 6x minus 2 equal to y, right? So that's also a parabola. So anytime you have an x squared term, doesn't matter if you have x squared, x or y term, it's become a parabola. So that's how you recognize a certain graph. And then what happened? How can I make a square? So if you have x squared as well as y squared, and they have the same coefficient, then you will have y squared equal to 9, say for example. So this is a circle. You have x squared and y squared term, and they are of same coefficient. So if you say 4 and 4, there would be a circle. But anytime you have x squared and y squared having a different coefficient, like this, when it's 4 and 2, it become ellipse. Okay, it become an ellipse. And if you change this to subtraction, it become a hyperbola. Okay, so again, so this is a hyperbola when the x squared and y squared has opposite coefficient. If x squared and y squared has 5y squared has the same coefficient equal to 6, then it's a circle. And if they have different coefficient but they're of the same sign, like y squared, so they're both positive, x squared and y squared, so equal to 9, then it's a ellipse. Okay, if it is bigger, so 9, then you have a okay, so you have a ellipse that is more, so like let's make it bigger, 36. So it would be more flattened. So it depends on if you have x squared and y squared and the relative size of it. But they are in general circle. If they have different signs, so you have x squared and y squared term, but they have different coefficient and an opposite sign, then you have a hyperbola. Okay. So let's go to our next set of systems of equation where we have one graph representing a circle. You can see it is 1 and 1, right? And this is an ellipse because they are both positive terms. One is 4 and one is 1, so they have different positive numbers. And you can see that you're solving a system where you have a circle and an ellipse. The ellipse could be a vertical ellipse or a horizontal ellipse. So now this may have one solution. We talked about that before, right? They could have one solution where they only touch one point. They can have no solution. They can have two solutions or 3 or 4. The most that they can have is 4. So to solve this kind, because they only have x squared and y squared term, it makes sense to do elimination. Okay, you can use elimination where you eliminate x or y squared. X squared or y squared. So in this case, I would like to eliminate y squared. So maybe the best way is to multiply this by -1, right? You have an opposite y squared with the y squared in the first equation. So I'm going to write the -1 times x squared plus y squared equal to 10. So it becomes negative x squared minus y squared equal to -10. So I'm going to add to 4x squared, because by elimination means you add them, right? Plus y squared equal to 13. And when I add this, goes away. I have 3x squared equal to 3, right? X squared is equal to 1. If x squared is equal to 1, then I can find x is by doing square root plus and minus square root 1, because I will square root both sides and it will have 2 plus and minus. Then what about y squared? So if x is plus and minus square root 1, what is y? So I plug it back into back substitute. Substitute back into the original equation. So x squared plus y squared is supposed to be 10. So I plug in x squared. I don't plug in x. I just plug in x squared, which is equal to 1, plus y squared is equal to 10. So y squared would equal to minus 1 is equal to 9. And I do the square root again. Y is plus and minus square root of 9, which is plus and minus 3. So it seems like I have two solutions, right? So this is actually plus and minus 1. 1 and 3. And negative 1, negative 3. But actually not. I would have 1, 3. 1 and negative 3. Negative 1 and 3. And negative 3 and negative 3. So it's 4 sets, different sign. Because when I have x equal to plus and minus 1, I could have any of the y, right? So when it is 1, you can have y be equal to 3 and negative 3. And when it is negative 1, you also can have 3, 3 and negative 3. Oh, this is negative 1. So solve any method. So another one is you can use substitution. Actually, you can use elimination. So let's try to use substitution. So I have x squared and y squared. So maybe I'll just say x squared is equal to 5 minus y squared. I can use substitution, right? So what happened? So you would substitute to 1, because I get this from 2, so I substitute to 1. So whenever I see x squared, I do 5 minus y squared. So I would say 5 minus y squared plus 8y squared is equal to 40. Just distribute it out. 5 minus y squared plus 8y squared is equal to 40. So 7y squared minus 5 equal to 35. Divide by 7, y squared equal to 5. Y would equal to plus and minus square root 5. Okay, so don't forget the plus and minus. Square root 5. And what about x? So I use this. X squared is equal to 5 minus y squared. Y squared is 5. 5 minus 5 is equal to 0. So x squared is equal to 0. X is only one number, 0. So this is the case where I have only two solutions, 0, square root 5, 0, negative square root 5. The third one is, the last one, we can look at it, is this is a circle, right? So this is a circle. And x squared plus 8y squared, this one is an ellipse. Because you have x squared and y squared, but they have different coefficient of the same sign. The last one would be a circle and a hyperbola. You know which one is a circle? Well, actually, it's not. It's not a circle. This is not a 2, so it is actually an ellipse. And then a hyperbola. They have different sign in the coefficient. So this is a hyperbola and this is an ellipse. So it's kind of like the flat things. And then the hyperbola are those that have two branches, right? Like that. Ellipse are either this vertical or the horizontal. So how do I solve this? Oh, I think it's the best way is to do elimination, because if I add them, so just copy it down. 2x squared plus y squared. You almost can treat it as just x and y, but it just happens that they're x squared and y squared, right? Now you add them. So the x squared, the y squared goes away. You have 3x squared equal to 16. Is it 12 plus 4, 16? So x squared would equal to 16 divided by 3. Now you're going to do the square root of 16 over 3. That is 4 over root 3. Oh, plus and minus. I don't want to rationalize it. It's okay. So that would be x, 2 number. What about y? Use substitute, back substitute to 2. X squared is actually 16 over 3, right? Minus y squared is equal to 4. So negative y squared is equal to 4 minus 16 over 3. I subtract 16 over 3 on both sides. So 12 over 3 minus 16 over 3. That is y squared, negative y squared. So negative y squared is equal to negative 4 over 3. Y squared is actually 4 over 3. So when I do square root is plus and minus 2 over root 3. So again, it's root 3 at the bottom. So time to write the number, the intersection. So x is 4 over root 3. Y is 2 over root 3. But there is a case of negative, so you say 4 over root 3, negative 2 over root 3. And then you would have negative 4 over root 3 for x, because it's plus and minus. And then positive y, both negative. That's the answer. So this ellipse must have intersect with the 2 branches of the hyperbola. So that's how you solve nonlinear equation, nonlinear systems.